Hello, this is my final project for MAC2233, Calculus for Business Social Sciences. The business I created is called Just Eat It. It's a new company that is making edible cutlery to reduce the use of plastics and waste in the world. Our cutlery is made of organic corn and can be eaten or composted. We use the finest organic corn to produce durable, quality, and sustainable cutlery. Your meal is not over until you eat your fork. This ties with Sustainable Development Goal 12, ensure sustainable consumption and production patterns. One of the goals' intention is to reduce waste. There is a major problem in the United States and the world with waste and plastics. According to the source NPR, every year the average American goes through more than 250 pounds of plastic waste, and much of that comes from packaging. According to BBC News, the world produces over 2 billion tons of municipal solid waste every year, enough to fill over 800,000 Olympic-sized swimming pools. Per head of population, the worst offenders in the United States, as Americans produce 3 times the global average of waste, including plastic and food. Just Eat It has a mission to reduce the use of plastics in the United States and world, as well as reduce the amount of waste produced. Its solution is to produce cutlery, forks, spoons, knives, made out of organic corn as a replacement for plastic cutlery. The goal is to reduce the use of plastics and waste in the United States and the world. This is the business logo, an advertisement. Just eat it. You're not done with your meal until you eat your fork. The calculus topic is dealing with derivatives. Derivatives is defined as the function's instantaneous rate of change at a certain point. Extrema is any point at which the value of the function is largest, maximum, or smallest, minimum. There are both absolute and relative or local maxima and minimum. I chose this topic because it allows me to find the best price for each cutlery set and maximize revenue. Applications delivered include marginal cost, marginal revenue, marginal profit, finding extrema, finding elasticity demand, and many others. The data that I have shows the price for a case of cutlery and the revenue. $80, $250,000. $85, $310,000. $90, $375,000. $95, $320,000. $100, $260,000. $105, $190,000. The input is price, output is revenue. I made a scatter plot of the data, and I did cubic regression. This leads me to my revenue function, R being revenue, P being price, of 20p cubed minus 6,371.43p squared plus 659,928.57p minus 22,012,857.14. This equation is the cubic regression. Input is price, output is revenue, and the domain is from $75 to $115. In this project, we're going to find the extrema of the function, the best price to maximize revenue, and any points of inflection. I have a scatter plot of the data, and you see the cubic regression goes through that data. So, to find the extrema of the function, there are 3 things we need to find: the stationary, singular, and endpoints. For the stationary point, we're going to find the derivative, set the derivative equal to 0, and solve for x. So, when we take the derivative, we get 60p squared minus 12,742.86p plus 659,928.57, set it equal to 0. We're going to use a quadratic formula where a is 60, b is negative 12,742.86, and c is 659,928.57. This gives us 2 solutions of price, 122.85 and 89.53. Since the price of 122.85 is not in the domain of 75 to 15, it's not going to be a possible extrema point, which leaves us with one possible stationary point of $89.53. To find the singular point, we look at the first derivative, and there's any value of x, or p in this case, that makes it undefined. In this case, there are no singular points. And then for the domain, we look at the domain provided for the endpoints, and we get 75 and 115. Then our possible extrema are the 3 points 89, 53, 75, and 115. We plug them into the original revenue. So if I charge $89.53, the revenue would be $352,351. If I charge $75, the revenue would be $80,000, and $115 per case, the revenue would be $34,267. And looking at the graphs of each of them, we find out that at price $89.53, that's an absolute maximum. At price $75, that's a relative minimum. At price $115, that's an absolute minimum. So, according to this information, the best price, which is the absolute maximum, is to charge $89.53 per case of cutlery for a maximum revenue of $352,362.62. To find in points of inflection, we take the second derivative of the original function, which is 120p minus 12,742.86, set that equal to 0 and solve. That gives us a price of $106.19. We take that price, plug it into the original revenue, and we get $167,339. So the point of inflection for this function is at a price of $106.19 for a case, where the revenue would be $169,339. So in this project, first of all, I learned that collecting data is important for business, so I can do regression to estimate and see what's going on with my data. Secondly, I learned that finding streaming can help me find the best price to maximize revenue. Overall, that I learned that calculus is essential in a business to help maximize revenue. And finally, I learned that sustainability is important not only to the world, but to business. Sustainability is important to consumers and is a responsibility of everyone, including businesses. Thank you.